So for example, let's say we are given a function like, you can choose if you have a function from E, I can use your function, or let's say e to the x minus 2. Okay, so you can use transformations. So one option is, if the problem says use transformations, then you are done in a blink almost. But you still have to present, in any situation, you have to present domain, you have to present range after you graph it, you have to present asymptotes, if any, and you have to find the x and y intercepts, if they exist. For transformations, I don't request a table of ordered pairs, but for any other method, you have to present. So this is here for any other method. This is here, plus table of ordered pairs. Okay. Good, so if I use transformations quickly, I know I have to show all of them. I will graph e to the x, and I know e to the x is an increasing function, increasing on all its domain. This is the function, I call it the COVID function. It's a dangerous function, right? One person sick today makes 1,000 sick tomorrow, right? It's a very fast increasing function. So as e is to e to the x, I have to show that it passes through 0, 1, because when x is 0, y is 1. And the next one, so first here I have to know that this is y equals 0 is a horizontal asymptote. And e to the x minus 2, I have to show that the horizontal asymptote moves down to, it moves down here. So y equals -2. And now I will be shifting the graph 2 units down. So this point, 1, 2. I don't know exactly where the function crosses the x-axis, but I know exactly where it crosses the y-axis. And this is e to the x minus 2. The domain for this function, like for any exponential function, is all real numbers. Very clearly, the function starts at -2, not -2 to infinity for the range. Open -2 to infinity. The function has an asymptote, which is y equals -2. Horizontal asymptote y equals -2. Now the x and y intercepts, this is very clear. The y-intercept is 0, -1. In order to determine the x-intercept, right here, this value, I have to set y equal to 0, which means e to the x minus 2 equals 0. I move 2 to the other side, it changes its sign, or add 2, e to the x equals 2, and I have to remember how to solve this equation. Okay, I have to apply natural log to both sides. X goes in front and natural log e is 1. So it's x equals natural log 2. So now I can write the x-intercept is natural log 2, 0. This point here is natural log 2, 0. So just simply grabbing the graphing calculator, and I saw this here, and just putting in y equals e to the x, and then -2, then graphing it. Oops, I did something. Let me open my emulator here so it's easier for me to show you what I'm. And copying that graph means nothing. My beginning algebra can do that, but you're in calculus. You know how to analyze all this. I'm still clicking on my device here. 1 second, I'm going to share my screen. So also remember one other thing, that when you put this in the graphing calculator, the graphing calculator is not capable as you are, to know when to graph an asymptote. It's not capable. You have to put it by hand. Okay? So then when you click on graph, let me see, I don't know what if I have the zoom standard or not in there. Here it is. But this is lying to us. Do not copy something like this. I know if somebody copies something like this immediately. First of all, the graph doesn't stop here, and these two are not overlapping. If I change the scale on the y-axis, you'll see what happens. So this appears that it starts at -2, which is false. So if I change the viewing window and I go from, let's say, -3 to +2, you're going to see something totally different. Okay? And now it appears that it stops at what? -4, which is still wrong. So I know exactly when a student copies something like this. It's not what we're trying to do here. Okay? So the graph continues forever, and eventually, at -infinity, they may be closer and closer. I mean, very close. But no, they don't touch here. So I know exactly when a student does this, maybe graphs the horizontal asymptote and does this. Oh, I know that the student copied this from the graphing calculator because it's incorrect. Okay, so that was one graph. I'm going to show a table of ordered pairs, not for this one, but for a different one. And I would like to talk about the piecewise defined function. You have multiple piecewise defined functions in all the classes. So I'm going to choose a simple one. Let's say f of x equals, I don't know, x plus 2 for x less than or equal to 0. And let me put 1 here. I'm going to erase that. And 1 over x for x greater than 1. Okay, so a piecewise defined function is a function that is defined in 2 pieces or 3 or 4 and so on and so forth. I do have to show the table of ordered pairs. First of all, this interval changes into -infinity to 1, and this interval changes from 1 to infinity. Not necessarily, but this is an example. I realize that the function is defined on all real numbers. So from -infinity to infinity. And there is something very important that happens at 1. Of course, 0 has to be in the table. These have to be in ascending order. At 1, I have a bracket facing left exactly underneath 1. And facing a parenthesis facing right exactly under 1. Why? Because this piece of the real line uses x plus 2. And this piece of the real line uses 1 over x. So when I plug in 0, I get 2. Of course, I have to use, or you have to think of always of the x and y intercepts. -2, I have 0. When I plug in 1, I have 3, right here inside the bracket. When I plug in 1, I have 1. When I plug in 2, I have 1 divided by 2, or 0.5. That's all I need. Okay, when I graph this, notice that I'm gonna use 2 different colors. I'm going to use these 2. I'm going to use black for x plus 2, and I'm going to use green for 1 over x. The function is the whole thing. The reason I'm using 2 colors is because I don't want to see something like this. If you graph something like this, that is incorrect. This is not even a function. It's not going to, okay. By the vertical line test, this is not a function. So you have to be extremely careful. So -2, 0 is right here. 0, 2 is right here. And 1, 3 is right here. All full points because of the bracket. and I see this is a line, no problem. I'm done with this. I put it aside. Okay, then I have from 1, 1, but this cannot be a full point because then the function will not be a function. And then I know that at 2 is 1/2, and I know the graph. Okay, so this is the graph of the entire function f of x. And now I can present its range. The range goes from negative infinity, yes, 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 till 3. You don't have to write the domain again because I see it in your table. So learning this procedure is extremely important because in chapter 2, which no one has started, and our first test is a week from Sunday, so I'm a little worried about it. This will tell you the limit from the left, and this will tell you already the limit from the right. You don't even have to graph the function. And then if the limit from either side, if we are asked to find the limit from either side, you will say dne because from the left is 3 and from the right is 1. And the table already gives you that. So that's another example that I wanted to show you. Now I saw some graphs, something like this. What is this? I mean, how can I give credit for this? What is it? What does it mean? What is the unit here? What is the unit here? So when I graph the function, I have exactly the points that I presented in the table. I didn't copy anything from the graphing calculator. I showed step by step all my work. Each and every point is here. This is here. This is here. This point is here. This point is here. And this point is here, 2, 1/2. I can give credit for something like this. Then I saw somebody printed out the skills assessment from WebAssign, and there are several graphs and said check. What do I mean? What do I mean by this? There is no work. It doesn't show anything. I mean, just checking a graph, I can't give any credit for that. Again, somebody copied something like this. Well, I know that this is copied from the graphing calculator or from some software, but this is not. What is this? So please, please, I want to see your work step by step, because that's what counts, and that's what matters. Is there any particular type of problem that you would like me to work on?
I have a question about what you showed before with
Yes.
the piecewise function. On WebAssign, the piecewise function only asks for 2 values of it, like plugging it in. What work would we show for that? Would we just show that we plug in like -7, for example, in for x or whatnot?
Yes, but what I'm saying is we always look for the x and y intercepts. Those have to be determined no matter what. Yes, for a line, you do not need 3 points. I agree with you. 2 points are enough. But I have to find the x and y intercepts, and this is a mandatory point. If you stop here and don't present this piece, the graph is incorrect.
Yes, but on WebAssign, it only asks to like evaluate 2 different
that's fine.
y values.
Yes, but in chapter no, you are correct. Okay. But in chapter 2, you're going to need this.
Okay, I just wanted to make sure.
Yes, and this session is also presenting something that needs to be learned for the test, for test 1. So yes, no, if the function is given and they say just find f of -3, you will plug in -3 plus 2 and you say that's -1. Done. But if the problem is asking us to graph it, we have to present domain, we have to present range, we have to present the graph, and we have to present a table of ordered pairs. All this. If you don't like a horizontal one, you can use a vertical one. It will take you more space on a page. That's why I always use the horizontal, and this is the x-axis, right? The x-axis is not vertical, it's horizontal. But it's up to you. I'm fine if you use a vertical table. Perfect question. Anything else you would like me to show? Any other type of problem? Make one up or anything.
If we have a specific question, if we would like you to review our skills assessment work and like show us which ones require more work, is that possible? Just to send you an email with that?
Of course. Of course. Okay. Of course. But again, if you simply look at, I'm just going to, is there any particular type of problem that you had difficulties with? Now is the time to discuss that. Anything that you would like me to, just tell me what the topic is and I'll make one up myself. Now, for example, reading from a graph. So if I have a graph like this, let's say the domain is between -1 and 6, and the range is between 1 and 7. If I'm asked to find f of 2, I draw a vertical line, or imagine I draw a vertical line at 2, and I read this value, the y value, right? If I'm asked to find the x value so that f of x is 4, then I have to draw a horizontal line, y equals 4. It meets the graph in 1 point or more, who knows, and then I will be reading the x value, let's say 5. So then I say that f of 5 is 4, and I read from this point.
If we're in a question like that and it asks to estimate it,
you have to say, yeah, just approximate. Yes, of course.
Okay.
This is not always possible to be exact. Yes. Other type of problem that you would like me to go back to? Anything? Okay, I have 2 chats. Yes. What? Yeah, I got that. Good. So for those of you who were not here on Sunday, or maybe did not get even the chance to look at the video that we made at that time, I'm just going to share my screen again and show you under modules. I need to caution you because this is